In this video, you're going to learn about the greatest common factor. So first off, what does the greatest common factor, or GCF, mean? So the greatest common factor between two numbers is the greatest integer that is a factor of each. So for example, if you were to find the greatest common factor of 8 and 12, so 8 and 12, so the factors of 8 would be, you have 1 times 8 and 2 times 4. So it'd be 1, 2, 4, and 8. For 12, you have 1 times 12, you have 2 times 6, and you have 3 times 4. So you have 1, 2, 3, 4, 6, 8. So what you do is you try to find the largest one that they both have in common. Well, they both have a 1, they both have 2, they both have 4, sorry, not 8, there should be a 12. And then that's it. So 4 is the biggest number, the biggest factor that they have in common. So the greatest common factor is 4. And that's because that's the largest number that can be divided evenly into both 8 and 12. Now we don't want to have to go through this process every time because with bigger numbers it's going to be more difficult. So here's a process that we can use to find the greatest common factor. So using the same numbers, 8 and 12, what I can do is I can take the 8 and find the prime factorization of that. So 8 is composite, but I can break it up as a product of 4 times 2. 4 is still composite. I can break that down as 2 times 2. And the 2 over here is prime already. That cannot be broken down any further. So I can think of 8 as a product of 2 times 2 times 2. Now looking at the 12, I can do the same thing. 12 is a product of 4 times 3. And then 4 can break down as a product of 2 times 2. And then 3 cannot break down any further. So 12 can break down as a product of 2 times 2 times 3. So once you have found the prime factorization of both or all the numbers that you are working with, what you can do is you can look to see which factors they have in common. So notice they both have a 2, and then they both have another 2. So if I take those numbers and multiply them together, the two 2's, 2 times 2, my greatest common factor would be 4. And as we notice, that is the same answer we got earlier. Alright, let's get some practice with this concept. Here we are to find the GCF, or greatest common factor, of 12 and 24. So going through the process, I can break 24 down as a product of 4 times 6. 4 can break down as 2 times 2, and 6 can break down as 2 times 3. So 24 would equal 2 times 2 times 2 times 3. Alright, and then with the 12, 12 can break down as 4 times 3. 4 can break down as 2 times 2. So I have 12 equaling 2 times 2 times 3. So from here, once I have done this, I can then see what factors they have in common. They both have a 2 in common, and then another 2 in common. And they also have a 3 in common. So if I take the 2, 2, and 3, multiply them together, that would give me 12, which is the greatest common factor. Which makes sense. If I take that 12, 12 is the biggest number that you can divide into 12 and also 24. I can divide 12 into both with no remainder, so that would work. Okay, example 3, we now have 3 numbers, 12, 24, and 30. So looking at the 24, 24 is 4 times 6, 4 is 2 times 2, and 6 is 2 times 3. So 24, not 8, 24 is a product of 2 times 2 times 2 times 3. And then 12 would be 4 times 3, and then 4 is 2 times 2. So we have 12 equaling 2 times 2 times 3. And then with the 30, 30 can break down as 5 times 6. 6 can break down as 2 times 3. So 30 can be written as 2 times 3 times 5. Now looking at all three sets of numbers, I see which ones they all have in common. So they all have a 2 in common, and they all have a 3 in common. So the greatest common factor of all three of these numbers would be 2 times 3, which is 6. And that makes sense because 6 you can divide into 12 evenly, and divide into 24, and also into 30 with no remainder. Now lastly, we can also incorporate variables. So here we have 10x to the 4th times y, and 15x squared y squared. So if I can think of 10 as a product of 2 times 5, and then x to the 4th, you can think of that as 4 x's multiplied together, x times x times x times x, then you have the y here as well. 15x squared y squared, I can think of 15 as 3 times 5, then x squared is x times x, and then y squared is y times y. So to find the greatest common factor, even with the variables, it's the same exact process. So we see what factors they have in common. I see they both have a 5, they have an x, another x, and they have a y in common. So the greatest common factor would be 5 times x times x times y. And then x times x, I can write that as x squared. So the greatest common factor of those two expressions would be 5x squared y.